y is equal to secant x and y equal cosecant x. Graphing a secant. In fact, here is a cosecant function because the graph of two full periods y is equal to the CSC. It means it's a cosecant. X plus pi over 4 for minus pi over 4 to in the interval between minus pi over 4 and 3 pi over 4. So first of all, here the cosecant, this function here, cosecant, is related with the sine, is the reciprocal function of the sine x. First of all, let the graph of the function y is equal to the sine x. So let me take a different color. And I am working with the function y is equal to the sine x plus pi over 4 because the cosecant x plus pi over 4 is the reciprocal function of the y is equal to the sine x plus pi over 4. First of all, if we are looking at the function sine, here we already see the amplitude is 1, so we don't have to care about the amplitude because here is the range is from minus 1 and to 1. That's what we know. But now here, if we are looking for the period, and in the front here b, so let me write what kind of the function is this one. This function is a sine of bx plus c, so general form of this function. B here we already see is 1, and if we are looking for the period of the function is going to be equal with the 2 pi divided by b, but because b is 1, 2 pi divided by 1 is just a 2 pi. So the graph here is a 2 pi. But now we are looking, we have this x plus pi over 4, we have a phase shift of the phase of the function. So we're taking this x plus pi over 4 and equate with 0. And when we are subtracting both sides with minus pi over 4, it turns out x is equal with the minus pi over 4. That's what we have here. What's happening here? It means that the function sine x is going to move for a pi over 4 to the left. So here is going to start. Okay, this is a minus pi over 4. So let me see, minus pi over 4. So here it says from here they wanted to restrict the domain from minus pi over 4. But what happened? We already know. So just let this 2 pi, if I divide it in 4 pieces, we already know, we are familiar with this division here. Here is going to be 0, pi over 2, pi, 3 pi over 2, and 4 pi. So if I'm dividing a 4 pi by 4, is going to be equal with a pi over 2. So every space here is a pi over 2. But now, in order for us to reach it from minus pi over 4 to pi over 2 to this point here, we are adding the distance pi over 2. Minus pi and pi over 2, we already know pi over 2 is a 2 pi over 4. Minus pi plus 2 pi over 4 is a pi over 4. So this point here, pi over 4. If I add in here another pi over 2, which is going to be here, is going here, what is going here to be is going to be pi over 2 plus pi over 4, because every time the distance, the space is going to add a pi over 2. 2 pi over 2, 2 pi over 4 plus pi over 4 is a 3 pi over 4. And the other one plus 2 pi over 4 is going to be 5 pi over 4 here. And plus a pi, 2 pi over 2 is a 7 pi over 4. So this is one period of the sine function. And now if we are looking now with the sine function, we already know here is 1, right? And we go into this point. I'm trying to find the critical points where it's going to go. And the other critical point here is a minus 1 and 5 pi over 4. This one is a pi over 4 and 1. So in those points has to cross the sine function. And now let me draw with this with the red, maybe looks better. And I'm drawing the sine function. So this is how it's going this function to be. Okay, so as sine pi over 4. Those are the critical points. So here is a minus pi over 4 is 0. Here is, for example, I cannot write pi over 4. At this point, if you want to write here up pi over 4 and 1, 3 pi over 4 and 0. Here is a 5 pi over 4 and minus 1, and here 7 pi over 4 and 0, this point. But now, as I said before, because we are trying to find the cosecant x plus pi over 4, first of all, we are trying to find the vertical asymptotes. We already know the secant and cosecant, they have a vertical asymptotes. And what is going to be vertical asymptote? The vertical asymptotes here are going to be whenever we have those x-intercepts. When the graph of the sine function intercepts in the x position, there in those positions are going to be the vertical asymptotes. So let me draw this vertical asymptote. So already we know are here. So is a minus pi over 4, is a 3 pi over 4 is here, and the other one is a 7 pi over 4. And this continues in this form. And if we are looking now, for example, to find some formula that produces all the asymptotes, so x is going to be equal. So x is going to be equal. So as I see here I know is in every pi. So it means n pi is minus pi over 4. Okay, let me see. It's plus pi over 4. Okay, is a plus because here I have plus pi over 4 is a plus pi over 4. Let me see, can I do this one? If it's a 0, is a pi over 4. But I have 3 pi over 4. Let me see if it's a minus. Let me make a minus sign here. Is a 0 is minus pi over 4. So here should be minus sign. Okay, so let me take this out. So because I want to figure out where it's going to be. So if it's a 0, it means gives me minus pi over 4. Let me see is 1. Pi minus pi over 4 is 3 pi over 4. It gives me here. If it's a 2 pi, minus pi over 4 is a 7 pi over 4. So this formula can produce the vertical asymptotes in all these points here. In the left side or the right side, we can find all of them. We just prove it also 3 vertical asymptotes. So now let me see how we can draw the let me take some different color. Okay, so let me take a green. And now if we want to draw this function here, cosecant x, as I said before, is similar with the secant x. So this one is going to go in this side. Whenever is a maximum in a pi over 4 is going they to share both of this point with the sine x in this position, and the other one is going to be here. You see, and the end behavior of this function are going very, very closer to the end point. So the green one signifies y is equal to the cosecant of x plus pi over 4. And if we are looking for the domain of this function, we already have restricted here from minus pi over 4 to 3 pi over 4. But in general, I am talking. In general is from minus infinity to infinity in general. Except x has to be different from n pi minus pi over 4 when n is element of z is an integer. N is an integer, and the range of this function here is going to be from minus infinity is going to be to this point here to the point 1. So we see in the direction of the y-axis here is a minus 1. I'm sorry, it's minus 1, and included minus 1 is a union, and now we see from 1 here to infinity, from 1 to infinity. So this is the range.